Greetings, the AEL480 here yet again, and welcome to part 3 on this stereo amplifier build. Now, I've gone ahead and started marking some things out, like where the holes in the heatsink need to be drilled to mount them to the rails. I've also marked where my ground is and where the transformer is going to be. Now, I was reading the comments on the last video of this, and someone said that this panel looks like the top panel and they would have used the other panel as the bottom panel. What? They're both the same. They're exactly the same. There's no difference between the two panels. Anyway, that didn't make any sense to me. I think though the case is actually upside down, and I'll tell you why. Along the edge here we've got a series of 3 slotted holes, one slotted hole here in the middle, and nothing here that's blank. I reckon this top set of holes here should be at the bottom and the rest at the top. I believe I've got these side panels up the wrong way, but that's easy to fix because I'm going to have to take the bottom panel back off anyway when I'm mucking around with the heatsink, so I will just swap the sides over and then turn it over. So the first thing I'm going to do is I'm going to drill the top 2 holes in between these fins. I've already drawn around with a pen through the holes where they're going to be located in the vertical direction. So all I've got to do is just measure them and make sure they're horizontally centre. And I'm going to probably raise it up by a couple of millimetres or so, just so that the heatsink is not touching the panel. So I'll get to doing that. It just means I've got to take the power out modules off of the heatsink to do it. And yeah, I've also made up a JST connector from the multi-vibrator board to replace the power switch LED. So that's now long enough. So I'll get to drilling the heatsink, at least the top 2 holes, take the panel off, and mount it, then mark the other 2 holes and then drill it. So I'm only going to put 4 in there. 1, 2, 3, 4. And a short time later, probably about half an hour, I've got the 4 holes drilled out, tapped to M4, and I've taken it out of the case. It's easier to screw in that way. So now all I have to do is make sure it actually fits correctly in the case. If not, I'm going to be rather annoyed. Well, if not, I can always modify the holes in these rails to, massage it. But let's not get ahead of ourselves. The only thing holding these 2 sides on is the 2 screws at either side of the back panel here. So I need to bring this up to where it was, which was there. I believe, yes, I think that's right. And now see if I can get the screws to go in. Start with this end because it's convenient. Yeah, I've made a mistake. I've got the heatsink too far over this way. I'm going to have to move it along one and then try again. Oopsie. Right, with that error corrected, let's try that again. That goes over that side. And that goes there. That's better. It lines up with the edge of the panel now, which it should have done in the first place, but it didn't. And it looks like the holes will line up just fine with the rails. It didn't come out too bad. Being metal, it can be bent to submit a little bit. As long as it doesn't pull the case out of true, that should be fine like that. I'll just make sure they are tight, because this is not coming out again. Really wish I had some Loctite, because then I could make sure these screws don't back out. Alright, now I've got to put this one in, which is not too far off. Now, as long as everything looks straight and true, it doesn't really matter if it's not 100% straight. It's like when you're doing stuff like this by hand, getting it straight 100% is like, yeah, you know, next to impossible. Nice. And it looks like I've got a nice even air gap at the bottom and the top. As the top panel actually will sit over the top of these holes, not under it, then the panels, both panels should clear the heatsink just fine. So yeah, cool. Now, even though that this is actually the bottom cover, I've just got it sitting on top here because it's easier to work on. I've gone out and bought some of these stick-on rubber feet. It's HP0826, because now I want to, you know, stop this from sliding around the desk when I'm working on it. So I might as well put them on now, even though I haven't drilled this panel yet. It doesn't really particularly matter, because I'll be having a block of wood underneath it anyway when I'm drilling. I'll put it in line with the ventilation holes so that it lines up with the ventilation holes. And being on the bottom, it doesn't really matter. You're not going to see it. It just stops the thing scratching things or sliding around. Right, that's done. So now I can, well, work on the next bit. Alright, all the pilot holes are now drilled, so I can take off the tape. So, because I don't need it anymore, and then I can size out the holes accordingly. I know where everything is, so I don't need to keep the tape on there to tell me what things are, or have rude words on there. I just used the blank PCBs to draw around the holes, so I knew where they were, and put references like rail and heatsink on this side so I knew where the confines were. And so everything should fit inside the case nicely without interfering with anything. Wow, a lot of tape. But it's cheap. Okay, so now I need to clean off all this junk so I can see what I'm doing. I reckon all those holes will line up nicely. I've drilled them out to 3.5, so just to give it a little bit of wiggle room. Now all I've got to do is just drill out these two top holes to the correct size. That needs to be a 4mm, and that needs to be 6.5. Alright, with everything drilled out to size and deburred, I can now go about mounting all the components on the bottom panel, and then I will marry that up to the rest of the case. I've already got the star ground point put in. And I'm hoping that's making electrical contact with the rest of the metal. Well, it should. It's a 4mm hole, which is barely the right size for a M4 screw. It needs to be about 4.5. So let's just check this out. Put one probe there. Yes, it's grounded. Sweet. Okay, so we know that that's grounded fine, so let me get about assembling all the componentry. Okay, short time later, everything's mounted and the holes weren't too far off. Apart from my transformer, I'll mount that once the case is back together. Yes, this board is at a slight angle, but that's not really going to make a difference to it. Okay, so I'm now going to marry the two halves back together. This is kind of fun. Well, I wouldn't be doing it if it wasn't fun. Oh, yes, look at that. The heatsink just clears this PCB down here just fine. Everything else fits in there like I wanted it to. I mean, yeah, now thinking about it, I could have moved the power supply over that way a bit further. But it doesn't matter, it still all fits, so that's the main thing. Okay, now to screw the case back together, and there's only 2 screws there and 2 there. I might pop the sub panel back in. Well, actually no, I have to remount the power amplifier modules. So I'll get on doing that, and we'll come back in just a few minutes. Right, so now I just have to line this transformer up so that this connector can actually plug into the board nicely without being at a terribly funny angle. I mean, it is quite difficult to get in there. Maybe I need a little bit more slack, I don't know. Luckily that these wires are connected to the connector are actually soldered to the terminals, so it makes it easier to put in. Probably like that, I think, or like that maybe. Yeah, that might be a bit better, as long as I can still get the connector unplugged and plugged back in. Yes, I can. Alright, I'm going to tighten it up like that. Nice and secure. Alright, so I'm just going to power up the power supply now and just make sure that the thing still works and there's no shorts in the transformer now. Seems perfect. Gotta wait for the relay. There it goes. So it sounds like the power supply is working. So I'll just make sure that we've got continuity. Yes. Yes. Alright, so now I should measure voltages, I suppose. So I'll just measure between ground and the positive rail. 38.6, and now the negative and ground, 38.6 minus. Great, that means the power supply is functioning. So now I can turn that off, and I can move on to the next bit, which is reinstalling the power amps. Now, I want to get this wired up to a powerable state, that is, that the power amps are getting power and the regulator board down here, etc. Which means doing some internal wiring, which is the one part of any project I hate doing, is the internal wiring. So I might start with the ground up here, which you can't see. But I'll start with the ground and the grounds and then work my way up to where I need to have things. All the grounds are done now, and I actually did this cable that connects between here and the regulator board. I didn't discharge the capacitors or anything, and I left this plugged into the connector, and I went to shorten the wires and cut through them, and bang! Big flash and a spark in front of it. It's like, shit! Yeah, so after that I discharged the capacitors. I didn't do any damage. It slightly melted the end of the wire on the red one where I cut it, but yeah, that's a good lesson. Always make sure when working on something, especially when cutting through wires, they're still connected to PCBs that capacitors are discharged. Anyway, it all still works. So the next thing I've got to do is do these supply leads to the power supply, which are over here. And I've also got to do the output wires to the relay. And yeah, that's going to take me probably another hour to do. But at the moment, I have to start getting ready for work, so I can't do that right now, but I'll do it when I come home from work, and then we'll pick up where we left off. And then this should be in a powerable state, so it can actually, take an input signal and give an output. So, all going well, yeah, we should have something in the next few seconds for you, and a few hours for me. Alright, let's get on with it.
Aw, my pussy is wet.
Check it out. All the high current wiring is done. I actually did this yesterday. I just haven't got around to filming it yet. Ignore these two wires with the eyelets on here down the bottom, because they're for the actual output terminal sockets for the grounds, but they're not on the Star Earth at the moment. So I'm about ready to test this thing. It's already hooked up to the dummy load on both channels, and the signal generator, and oscilloscope, etc. So all I've got to do now is just turn some things on. I've also got a potentiometer there wired across the input of each power amplifier as a volume control, so I can hook it up to a source of music shortly. So I'm going to plug it into the dim bulb, and you can watch the oscilloscope screen. I can find where the plug is. There it is. I always seem to have an issue with focus when recording the screen of this oscilloscope. Anyway, I've got the volume control down pretty low, so I'll turn it on. Nothing happened. And there we go. Now, yes, we've got a signal, and I was just a bit confused there for a second because the level is different. That's because that setting has moved. Anyway, we're getting close to the same voltage output on both channels, around about the 2.1 volt RMS range, which is going to be roughly about, I don't know, 700 milliwatts or so. There doesn't appear to be any smoke coming off of anything. This heatsink here does get kind of hot to the touch, pretty hot, and that's the series passed element for the Zener regulator on the power supply PCB, but it doesn't get hot to the point where you can't really hold on to it for a long period of time. It's very hot to the touch, yes, but it's not going to burn the shit out of you, so it's not going to be like, you know, 100 degrees or something like a stovetop. So it should be fine. So I guess with both channels being driven now, I want to actually see how much power output we get before clipping. Yeah, that's not going to work on the dim bulb, is it? Okay, so let me just take it off the dim bulb now. Turn that off. Okay. Alright, let's try that again. Okay, turn it down. And there's clipping. It's oscillating a bit. About 58 volt peak to peak. So I'll kill that so I'm not overheating things. That's about 52 watts RMS, which is not too shabby, and that's both channels driven. And that's mainly due to the limitations of the power supply, and also the changing of these resistors from the 110 ohms to the 120 ohms has made it give a little less power. So I guess the next thing to do would be to hook it up to a couple of speakers and you know, see if we get a reasonably good output. So that's what I'm going to do now. Alright, I've got the TX speakers hooked up to it, so I don't really want to play music with it connected to the dim bulb, so I'll just connect it straight to the power. No noise, not a single sound. You can hear a slight little bit of a hiss with a buzz behind it, but it's not like a mains hum. Excuse me. And the other channel's doing exactly, excuse me, the same thing. So there's a bit of a reminiscent of old TVs, like CRT TVs. You could hear a little bit of buzz in the audio if you put your head close enough to it. Anyway, let's play a song. that's enough of that. It sounds absolutely fine. There's no unusual noises. The heatsink's still relatively cold. It's got probably a slight tinge warmth behind it, but it's nothing to write home about. So yeah, I'm actually quite pleased. It's always good when a project works first time you power it up, and you went to all that work and that effort just to get to this stage, you know. And it doesn't even have a preamp yet, which is, yeah, significant. And that control is probably sitting around about the 10 o'clock position. And it's still outputting quite a significant amount of volume. At the moment, what I was running into the speakers is probably about the equivalent of, I don't know, a couple of watts. That's between both speakers, obviously, not 2 watts per speaker. It's probably like, you know, a couple of watts between them, which is a little bit above normal listening level. But no, it's working and it's sounding absolutely fine. And apart from that slight little buzz in the background there, but that's just, you know, just a little bit of mains hum that's not being filtered. But it's not noticeable, it's not obnoxious, and yeah. And currently I've got just the inputs going into the power amps without the ground connected at the input. The shield goes all the way up to the end of the cable, but the ground of the input signal is actually at the star ground, so it seems to work fine in that configuration. However, with the preamp connected to it, ground's going to be coming off of the regulated outputs of the power supply, and that's where it's going to get its ground from, because that does ground back to the star earth. And yeah, it's probably not going to present that much of a big problem with like earth loops, is what I'm trying to say. So yes, we've got no earth loops. It sounds, you know, good for what it is, and I'm very happy with how this turned out. So, but this is not the end yet. I mean, there's a lot more work to go yet. There's a preamp, as I just mentioned, the headphones socket board, routing the power switch, a power switch board with a fuse on it, the input switching selector, and the actual input selector board itself. So, as well as drilling the front and rear panels. So all of that's going to be coming up in a future video. But for now, I'm going to leave this video here, and I hope you enjoyed it. If you did, please remember to go down below, like and comment and subscribe if you haven't done so already. Anyway, this is the Astro30 saying, see ya, have a great day. I am so excited.